Why is the thermodynamic limit important in statistical mechanics? Have you ever wondered how tiny particles can lead to the big behaviors we see in everyday life? The thermodynamic limit plays a key role in connecting these microscopic actions to the macroscopic properties we observe. Let's break this down in a simple way. Statistical mechanics is all about understanding how the tiny building blocks of matter, like atoms and molecules, behave. When we look at a real system, the number of particles is usually enormous, often around 6.02 times 10 to the 23rd. This is known as Avogadro's number. To make calculations easier, we consider the thermodynamic limit, which means we imagine a system with an infinite number of particles and a proportionally large volume while keeping the density constant. In this limit, the average values of important thermodynamic quantities, like temperature, pressure, and entropy, become smooth and predictable. This is because random fluctuations in energy or particle number become negligible compared to the overall size of the system. When we have a large enough system, these tiny variations do not significantly affect the overall behavior. This simplification allows scientists to use mathematical tools, such as the partition function, to calculate properties like free energy and entropy easily. The thermodynamic limit also means that the results we get do not depend on specific boundary conditions or the size of the system. This makes the description of the system universal and consistent across different scenarios. While microscopic fluctuations still exist, such as small density changes or Brownian motion, they do not impact the overall macroscopic properties. This is especially important when we talk about entropy and spontaneity. Entropy is a measure of disorder in a system, and in large systems, it behaves in a predictable way. Without the thermodynamic limit, connecting the behavior of individual particles to the stable thermodynamic quantities we use in science and engineering would be much more complicated. The thermodynamic limit helps scientists and engineers predict how materials and gases will behave under various conditions without needing to track every single particle. This ability to simplify complex systems is what allows us to design engines, refrigerators, and other technologies based on reliable thermodynamic principles derived from statistical mechanics. So, the thermodynamic limit is not just a theoretical concept. It has practical applications that impact our daily lives.